How we doing, everybody? This is That Our Nerd back at it again with another algebra tutorial. This one today covers dividing polynomials again, and the difference with this one is we're going to have a remainder at the end. So this one demonstrates what to do when you have a remainder at the end of your division problem. So we'll set up our division. All right, so this big chunk, the first part, we put under our division symbol. So we have 10 z cubed, and it's important to remember that you have to have each power descending all the way down. So z cubed, z squared, z, and then a constant here at the end. But if it's not there, you're supposed to put in a plus 0 z to whatever power it is. But for this one, we have all of them here. But that's an important thing to remember, that you need to put that 0 in if the power is missing. So we have 10 z cubed minus 26 z squared plus 17z minus 13. And we're dividing this by 5z minus 3. Okay, so our first step here is we're going to take our z cubed. So you take the first term of your dividend and divide it by the first term of your divisor. So we take 10 z cubed divided by first term in our divisor, 5z. So 10 divided by 5 is 2. Z cubed divided by z is z squared. So we have 2z squared. Again, for cleanliness, I just like to put our whatever power it is above the whatever power it is over here, if that makes sense. So this is a squared, right? 2z squared, so I put it above our z squared over here. So 2z squared. Now we multiply this term by the two terms in our divisor here. So 2z squared times 5z squared is going to give us 10z cubed. And this is a minus 3, right? So we take 2z squared multiplied by negative 3. It's going to leave us with negative 6z squared. Now we do our subtraction. Again, it's very important. We're subtracting everything within here, right? We're not just subtracting 10z cubed, we're subtracting a negative 6z squared as well. So 10z cubed minus 10z cubed, 0. So we know we got that one right. Negative 26z squared minus negative 6z squared. So this is like saying negative 26z squared plus 6z squared. And that would leave us with negative 20z squared. We can drop down our next term. So we have plus 17z. And rinse and repeat, I guess, here. So we have negative 20z squared, negative 20z squared divided by 5z. So we're trying to see how many times does 5z fit into negative 20z squared. And negative 20 divided by 5 is negative 4. Z squared divided by z is z. So it fits in there negative 4z times. So negative 4z, negative 4z. We'll take negative 4z times positive 5z. So that would leave us with a negative 20z squared. We'll take negative 4z times negative 3, and that'll leave us with a positive 12z. We now subtract negative 20z squared minus negative 20z squared. It's going to leave us with 0. And then we have 17z minus 12z. That'll leave us with a 5z. And drop our last term down here. That is it's a couple dots there. That's no help. That is a negative 13. So we do this one more time. We see how many times 5z fits into 5z, and honestly, we'll do it over here just for kicks and gigs, but you can probably see that this is just going to be equal to 1, right? So we take 5z divided by 5z, and 5 divided by 5 is 1, z divided by z is 1, And so this is just going to leave us with 1. So plus 1 here. So then we multiply out again. 1 times 5z is 5z. 1 times negative 3 is negative 3. And we subtract. 5z minus 5z is 0. Negative 13 minus negative 3, right? So this is going to be negative 13 plus 3. Leaves us with negative 10. And now, when we look and see how many times does 5z fit into negative 10, well, it doesn't, because this one doesn't have any z's down here. So this is our remainder. So for our final answer, we'll have 2z squared minus 4z plus 1, right? So that's this chunk up here. That's how many times it fits in. But then there's a little remainder at the end. And so for your remainder, you take whatever your remainder is. In this case, it's negative 10. So our remainder is negative 10 divided by whatever your divisor is. 5z minus 3. So that would be your final answer dealing with remainders. So whatever's left over at the end of your division problem, all you do is you put your remainder on top of whatever your divisor is, and that's it. Hopefully this video was helpful to you. If it was, make sure to press that like button down there. It's very helpful. Subscribe if you want to see more algebra lessons and tutorials similar to this one. And have a fantabulous day. Thank you.